There is something out there. Something so old, so impossibly distant, that the light reaching us right now left before the Earth existed, before the Sun existed, before almost anything existed. And when astronomers finally saw it clearly, truly saw it, they didn't just update a record. They started questioning everything they thought they knew about how the universe works. I'm going to tell you exactly what they found and exactly why it's so disturbing, but I need to save the most unsettling part, the thing that actually breaks the model, for the end of this video. Because if I tell you now, the rest won't hit the same way. Trust me, stay until the end. And real quick, before we go anywhere, where are you watching this from right now? Drop your city in the comments. I'm genuinely curious how far this reaches. The galaxy we're about to talk about traveled 13.4 billion years to get here. Where did you travel from today? Let's rewind. To understand why this discovery matters, you need to understand something about light and about time. When you look at a star, you're not seeing it as it is right now. You're seeing it as it was when the light left it. Our sun, you're seeing it 8 minutes in the past. The nearest star beyond our solar system, 4 years ago. The Andromeda Galaxy, 2.5 million years ago. Now, scale that up. The universe is roughly 13.8 billion years old, and the further out we look, the further back in time we see. Astronomers have a tool for measuring this. It's called redshift. As the universe expands, the light traveling across it gets stretched. It shifts toward the red end of the spectrum. The more stretched the light, the further it traveled. The further it traveled, the older it is. A redshift of z equals 1 means you're seeing something from about 7.7 billion years ago. Z equals 5 takes you back over 12 billion years. Z equals 10, you're almost at the beginning. For years, the record for the most distant galaxy ever confirmed was held by a galaxy called JWST Z14, spotted by the James Webb Space Telescope, redshift of 14.18. Its light left it just 290 million years after the Big Bang. That was already hard to comprehend. Then a team at MIT's Kavli Institute was going through existing Webb data, looking for something suspicious, an object appearing in infrared but dropping out completely at shorter wavelengths. That signature, that dropout, that's exactly what an ancient, ultra-distant galaxy looks like. So they looked closer.
In April of 2025, they pointed Webb directly at it. They used the telescope's spectrograph, an instrument that splits light into its individual wavelengths like a prism, but thousands of times more precise, and they read what came back. Just like that, the record fell. They called this galaxy Lamp Z14, and what they were now looking at was light that left its source just 280 million years after the Big Bang. Let's put that in perspective. If you compressed the entire history of the universe into a single year, one calendar year, the Big Bang happens at the very first second of January 1st. The dinosaurs don't show up until Christmas Day. Modern humans appear in the last 90 seconds of December 31st. Lamp Z14 existed on January 7th. And we built a machine that can actually see it. Now here's where it starts getting uncomfortable. Lamp Z14 is small, about 300 light-years across. Our own Milky Way is 100,000 light-years wide. We're talking about something 300 times smaller than our galaxy. And yet, it is screaming. It is blazing with light. Extraordinarily luminous for something so compact, far, far brighter than anything our models of early galaxy formation predicted should exist at that age. It's like finding a skyscraper in the middle of a field where the concrete was only poured a week ago. How is it that big, that bright, that fast? But that's not the part that broke the astronomers. When they analyzed the spectrum, the chemical fingerprint of Lamp Z14, they found something that genuinely stopped people in their tracks. A ratio. A very specific ratio of nitrogen to carbon. We've seen that ratio before. It shows up in globular clusters, ancient, densely packed balls of stars that orbit large galaxies. We've always assumed globular clusters took hundreds of millions, maybe billions of years to form. They're supposed to be old. They're supposed to be late. But LAMP Z14 already has their chemical signature. At 280 million years post-Big Bang, which means globular cluster formation may have started almost immediately after the universe became transparent. That's not a small revision to our timeline. That's ripping out a chapter and rewriting it from scratch.
Here's what would make this easier to handle. If LAMP Z14 were a freak, an anomaly, one cosmic outlier that we could file away and say, weird, but okay. It's not. Since the James Webb Space Telescope began science operations in 2022, it has found galaxy after galaxy in the early universe that doesn't fit. Too bright, too massive, too chemically complex for the age we're looking at. The pattern has been consistent, and it has been growing. Our standard model of cosmology, the Lambda CDM model, has been one of the most successful scientific frameworks ever built. Decades of observations, thousands of researchers, satellite missions, ground telescopes, supercomputer simulations, and it has worked remarkably well for most of the universe's history. But the very earliest epochs, the first few 100 million years, Webb keeps looking there and keeps finding things that don't fit. It's not that we're completely wrong. The model isn't broken at every scale. It's that something is missing from our picture of how the first structures formed. Maybe it's the way dark matter seeds early galaxies. Maybe star formation in the early universe was far more efficient than we assumed. Maybe the first stars, the so-called population 3 stars, burned so violently that they accelerated everything downstream in ways our simulations didn't account for. Or maybe it's something we haven't thought of yet. And here's what that means in practice. Every time Webb logs new observing time on the early universe, there is a real chance it finds something that forces another rewrite. The record for the most distant galaxy ever confirmed will fall again. That is not speculation, it is near certain. The question is only when, and what will be broken when it does. There's one more layer to all of this, one more thing that the researchers noticed, and this is the part I promised to save. This is the part that raises the deepest questions of all. Here it is. The light from LAMP Z14, those photons, they didn't travel in a straight line through empty, static space. The universe was expanding the entire time. Space itself was stretching underneath that light as it traveled, which means the galaxy that emitted this light is not 13.4 billion light years away from us. It's much further. Accounting for cosmic expansion, LAMP Z14 is now estimated to be over 33 billion light-years away from where we're sitting right now. And yet, we can see it. We built a mirror in space, a mirror made of gold-coated beryllium hexagons, cold enough to detect the heat signature of a bumblebee at the distance of the moon. And we used it to catch photons that have been traveling since the universe was a toddler. That is the thing that never gets said loudly enough. It's not just that we found a new record, it's that the act of finding it required human beings to collaborate across generations, across disciplines, across languages and borders to construct an instrument of almost incomprehensible precision, launch it 1 million miles from Earth, unfold it in the vacuum of space, and then point it at nothing, at a patch of sky that looks totally empty to the naked eye, and pull out a signal that changes how we understand the beginning of everything. LAMP Z14 is troubling, yes. It challenges our models, it rewrites timelines, it leaves open questions that will take years, maybe decades, to answer. But it also does something else. It proves that we can look. That we are the kind of species that builds instruments capable of seeing the first weeks of a 13.8 billion-year-old universe. That we don't stop at what we already understand. The universe is stranger than we thought. It was always going to be. The only question was whether we'd have the curiosity to keep looking. Turns out, we do. If this blew your mind even a little, share it with someone who needs to see it. Drop your thoughts below and subscribe if you want to be here the next time Webb breaks a record, because it will.